Hi there. 6th period trig dual credit from Mobansi. This is Mr. Gallagher. This is 1.3 notes video. The first thing we are going to do in this video, or I am going to do, is find right triangle values using SOH, TOA, and Pythagorean theorem. So for topic 1, we have a right triangle. Okay, and then we have an angle here. Call it angle A. We can call it theta. This is angle B. We can also call it beta. And this is angle C. It's 90 degrees. Okay, so SOH TOA is the sine is opposite over hypotenuse. The sine of the angle, either theta or beta, or whatever angle you're referring to. The cosine is the adjacent side, which is the one next to it over hypotenuse, and the tangent is the opposite side over the adjacent side. These are all lengths. Okay, so if this triangle was of lengths 3, 4, and 5, so the two legs were 3 and 4, and the hypotenuse was 5, you'd have 3, 4, 5. So the sine of theta, for example, is the opposite, which is 4 over 5, which is the hypotenuse. The cosine of theta is equal to 3 over 5. Adjacent means next to. So it's 3 over 5. And then the tangent of theta is equal to opposite over adjacent, so 4 over 3. Okay, now those can be applied to the cosecant, which is the reciprocal of the sine. The cosecant of theta is 5 over 4, and then the cosine of theta is equal to 5 over 3, and then the tangent of theta is equal to, or the cotangent. So I'm getting mixed up here, so my fault. So this is the secant of theta is 5 over 3, and the cotangent of theta is 3 over 4. So that's basically it. You use SOH TOA. Now, let's say another side was missing. Okay, so for example, I wanted to look at this triangle here. This is a right triangle. This is example 2. This is still topic 1, finding right triangle values using SOH TOA and Pythagorean theorem. Okay, so example 2 might look, I don't know, something like this. If I have 13 here, and I have 5 here, and I have theta right here. So our task is to find the 6 trig values of theta. So the sine of theta is equal to 5 over 13, opposite over hypotenuse. The cosine of theta is equal to, oh, no. So we have to figure out what the length of this side is, right? So we're going to use Pythagorean theorem. All right, so in a right triangle, Pythagorean theorem is if this is the leg, and this is another leg, and this is the hypotenuse, lengths, then the hypotenuse squared is equal to the leg squared plus the other leg squared. So whatever the lengths of those are, then you can use this formula to figure out what the missing one is. Only if it's a right triangle, though. Okay, always a right triangle. Okay, so how do we do this? Well, 5 squared plus that other leg squared equals 13 squared. That's the hypotenuse. So a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. Okay? Now, in order to do that, we get leg squared equals 169 minus 25 is 144. So the leg is equal to 12. So now you can find all the other ones. See, the cosine of theta is 12 over 13. And you could find the other 6. So sometimes you need to be able to recognize the right triangle, recognize where theta is, and use SOH TOA to find the values of the angle of the trig functions of the angle, So look at the right triangle. What are the three sides? And then go from there. Okay? Now, sometimes you need to sketch a right triangle. So finding right triangle values using SOH also gets us to problems like this. See, this is the example 3, topic 1. And if, say, the cosine of theta equals 5/6, I want to find sine theta, tangent theta. Okay, so no triangle here, but we draw a triangle. So we're going to draw right triangle. And the right triangle looks like this. And I put theta in here. And I'm going to use the cosine of 5π/6. The cosine of theta is 5/6, rather. 5/6 is the adjacent over hypotenuse. Now we have to find this side right here for sure. So 6 squared equals 5 squared plus my, I'll just call it L squared for leg. 36 equals 25 plus L squared. So 11 equals L squared. So L equals the square root of 11. So the length of this side is the square root of 11. Now you should be able to find all of the values. Now we have to be a little careful here because the secant of theta, for example, is going to be 5, it's going to be 6/5, so that's not a good example. But the cosecant of theta is 6 over the square root of 11, so we have to simplify that. So 6 times the square root of 11 over 11. So some of this does require a little bit of algebra. Okay? Now, I made a mistake. So basic, using Google to find degrees, minutes, and seconds. Let's see, did I need to do that? Is that even a part of it? Oh, that's loud. That might come a little later, but we can do that now. So I think I did that before, but let's do it anyway. So topic 2.